Hello there, my name is Maher Haddad. Today I'm going to show you how to configure a very complex OSPF scenario. So let's go to the website. Let's read the scenario. You work as a network engineer in a company. After studying OSPF routing protocol very well, you convince your CTO to use this routing protocol in the company's network. All IP addresses on all interfaces are already configured. Frame relay maps are already configured. Note that frame relay circuit on R3, R4, R5 is configured point to multi-point. So R3, R4, R5 are configured point to multi-point. And of course with sub-interfaces. And R3, R6 is configured as point to point with sub-interface. Then R3, R6 point to point with sub-interfaces. And then we have R1, R2, R3 connected to serial interfaces. Okay, let's check what's the first step. Configure OSPF area zeros on all routers and advertise all networks unless loopback 0 on R1. Okay, we can do that. So this is the graph over here, so we can see what we're doing. Configure terminal. Router OSPF 1 network 192.168.12.0 area 0. That's from router 1. Router 2. Of course, router 1 we did not advertise 1.1 as I said on the lab. Router OSPF 1 network. I will advertise everything. Area 0, and I will do show run section router OSPF. You'll be able to copy the configuration I did and paste it on all routers. Of course, we have to. It's okay. We can leave the log agency. Router 3, you can see adjacency is coming up. Router 4, router 5, and router 6. Okay, that's good. So let's check this next step. Ensure that loopback's IP address are advertised on an OSPF on all routers and you are able to ping them. If not, please check how to solve problems. Tips: problems could be from BDR reduction. So this means that if I am on router 1, for example, I have to be able to see all IP address of loopback interfaces which are on router 1 1.1, on router 2 2, 3, 4, 5 and 6. So let's check on router 1. I say show IP route OSPF. Okay, I can see 2, 3, 4 and 5 is missing, and 1 of course is not no OSPF, and it's already connected to our R1. So 4 and 5 is missing. Let's check here. Show IP route OSPF. Yeah, I see also 4 and 5 is missing. 2 is the router is connected to router loopback. Router 3, show IP route OSPF. And 2, 3 is himself, 4, 5 missing, and 6. So we see 4 and 5 is missing on all routers. Check here. Show IP route OSPF. Oh, there is no routing. Show IP route OSPF. Also, so 4 and 5 are not in the OSPF routing now. Show IP route OSPF. So there's a problem on router 4 and router 5, and the problem is if I go to router 4, for example, and I go to the sub interface which I configured for the frame relay. I say show IP or SPF interface serial 0/0.403, which is sub interface on here. And we can see here that the network type is non-broadcast. Router 3 also, if we do show IP or SPF interface serial 0/0.1, which is a sub interface for the point to multi-point, it's a non-broadcast. So router 3, 4, 5 is the network type is non-broadcast, and this means that they cannot see each other for OSPF. To solve the problem, I have to go to router 3 and router OSPF 1, and I have to issue the command neighbor 192.168.123.4, which is for router 4, and .5, which is for router 5. So let's do now. We see that we have something coming up. Show IP or SPF neighbor. So router 3, until now it has neighborship with 6, with 2, with 4, and 5 should be up in a moment. Yeah, but we still see that 4 is still attempting, so still trying. So we have to wait a little bit until this will come up. I assure you that this will come up. Okay, so we see now 5 is up. Okay, 4 and 5 are up, and yeah, that should be okay now. So if I go to router, if I stay on router C, I do show IP route or SPF. I should be able to see 4 and 5 now. 2, 3 is himself, 4, 5, 6. If I go to router 1, now I do show IP or show IP route or SPF. Then I can see 2, 3, 4, 5, 6, and that's what I need to see. If I do ping to 6.6.6.6, that will be fine, I think. Yes. If I do ping to the 5 and to the, you see a little bit my computer is slow. That's because I'm recording the video. So always when you have a non-broadcast, you should issue a neighbor command, and non-broadcast comes always on the multi-point, point to multi-point. Alright, that's fine. So let's go. So here they said tips problem could be from BDR and BDR, and that was not the case. Now, which router is DR in the multi-point frame relay circuit? Ensure that router 4 and router 5 can never be DR or BDR, as router 3 is the hub. So if we look to the graph here, router 3 is our hub, and those two routers should never be DR or BDR because they should go directly always from router 3. To do that, if I go to router 3 now, and I do show IP or SPF interface serial 0/0.1, I can see that the priority here is 1. If I check on router 5, for example, show IP or OSPF interface serial 0/0.503, and here priority is 0, which I already put it, but by default it's 1. But if you want that this router will never be a DR or BDR, you just have to put the priority 0, then it will never become a BDR or BDR. To do that, because I did it when I was practicing this lab, but I will show you how to do that. So all you need to do is you have to go to configure terminal, interface serial 0/0.503, and here you say IP or SPF priority and question mark, and here you put 0. So in this way you put the priority 0, and there will never be a DR or BDR also for router 4. So that's why if I issue from router 3 if I do show IP or SPF neighbor, you can see that 4 and 5 are other. Okay, let's go to the next step. Issue OSPF MD5 authentication R345 and ensure that you have neighborship again between routers. So 3, 4, 5, I have to do authentication MD5. So I go to the interface 00/0.1 and here I write IP OSPF authentication message digest, and then IP OSPF message digest key 1 MD5, and I will use a key name Cisco. That's router 3. I go to router 4 interface 00/0.403 IP OSPF authentication MD5 authentication message digest IP OSPF authentication IP OSPF message digest key 1 and Cisco. MD5 Cisco. Sorry, should be Cisco. Cisco. And router 5 also, I'm in the sub interface IP OSPF authentication message digest IP OSPF message digest key 1 MD5 Cisco. Alright, now if I go to router 3 and I do ping 4.4.4.4, okay, I still have reply 5.5.5.5. I have replies, so everything is well. Alright, then point number 5, issue OSPF plain text authentication between router 3 and router 6 and ensure that you have neighborship again between router 3 and router 6. Router 3 and router 6. I go to interface serial 0/2.1 IP OSPF authentication, enter, and IP OSPF, here I write authentication key 1, and let's name it curses. And then now router 6, configure terminal, interface 00.603 IP OSPF. You see here that the neighborship is down because there is a problem in authentication. IP OSPF authentication, IP OSPF authentication key 1 curses. And now after I issued this command, it should be up, and we can see that it's up. So if I do here show IP OSPF neighbor, I can see it's full and up. Alright, next step, change hello timers on all routers to 3 seconds and dead interval to 15. I'm not going to do that, but I will show you only on one router how to do that. But you should do it on all routers, otherwise you will lose neighborship. So again, we want to have to do hello timer 3, dead interval 15. So if I go to router 1, interface 0/0 IP OSPF hello 3 and IP OSPF dead interval 15. This is how we can do it, and directly when we do that we should have no any more neighborship. So I will take out the comments. So you should apply this to all your routers to ensure that you have neighborship always. Okay, now change the router ID on R2 to 22, 22, 22, 22, and ensure that all neighbor routers can see the new router ID of router 2 on the OSPF adjacency table. Okay, so I go to router 2. Now it's back on router 1 on because I put the no before the dead and hello interval. So on router 2 now, router OSPF 1, and to change the router ID I have to write the router ID 22, 22, 22, 22. Now it says that you have to clear the process of OSPF to take effect, and I will do that. Clear IP OSPF process, yes. So now it's clearing the process for SPF and coming back again. So now if I go to router 1, as it's a neighbor for it, I do show IP OSPF neighbor, and I can see now it's 22, 22, 22, 22. Okay, next step. Remove R1 and S0 over 0 of R2 from area 0. Okay, R1, no router OSPF 1, and R2, no. No, on R2 I will take out because we have to take out this serial interface. So what I would do is I would say router OSPF 1, no network 0, 0, 0, 0, and I will say here network. I will populate this network and this loop back to area 0, and then this 0, 0 over 0 to area 1. So network 192.168.23.0 and network okay. So I took out router 1 and 0 over 0, 0 over 0 on router 2 from area 0. Now configure router 1 and router 2 as 0 over 0 on OSPF area 1. Okay, so I go to router 1, and here I will say router OSPF 1 network 192.168.12.0 area 1. Of course, this loopback I will keep it because I will use it later, so I will not advertise it. And then on router 2 I have to say router OSPF 1 network 0 area 1. So now I should form a relationship between these two routers. So if I go to router 1, I do show IP OSPF neighbor, then I have neighborship here. Okay, now on router 5 I have to create this loopback interface. One that should be 2, 3. Okay, so I'll copy this one to create it. So I'll go to router 5 just to have the picture in front of us. Interface loopback 1 IP address, and then loopback 2, and then loopback 3, okay. So I created this loopback that will be advertised directly to OSPF because I used network 0000. So now ensure that R1 can see only one entry for those loopbacks in its routing table. So if I go to R1, I do show IP route OSPF. So we can see that's inter area, and I can see these 3 loopback here. So they want us to have these 3 loopback as one entry on the routing table of R1. To do that, I have to go to the border router, area border router, which is R2. I was there, so I have to say router OSPF 1, and then I have to say area 0, which the loopback are in, and then range, and I do the summary address, which is 172.16.0.0. You should know how to do the summary address. So this is the summary address of these 3 loopback, and enter. So now if I go to router 1 and I do show IP route to OSPF again, okay, we can see that we have only one entry now, which is the one we just entered now, /22. Okay, so we go to the next step. Of course, to show you that I can now ping any of these interfaces. What we have .1.5. You see here I have a reply. Okay. Now configure static route on R2 or static default route on R2 to loopback 0 on R1, and ensure you can ping the IP address of the loopback. So I go to router 2, and I say first let me ping 1.1 to ensure that I cannot. That's the IP address of the loopback of router 1. So as you can see, I cannot have a ping to this interface. And now I have to say configure terminal IP route 0000. So that's the default route to go to 192.168.12.1. Okay, so now if I do ping 1.1.1.1 on router 2, that should be fine. And if I do show IP route, we can see that the default route is shown. So it's gateway of last resort, is 12.1 to anywhere. And this is the static route which I have created. Okay, that's nice. So now make the change needed so that all routers in the network can ping 1.1.1.1. So for now, router 2 can ping the network, but router 3 cannot ping it. So if I do ping 1.1.1.1, I should not be able to do that. Even from router 3, which I'm trying now, 4, 5, and 6, the same result. So to solve this problem, I have to insert the default route into the OSPF. And to do that, I have to go to router 2, from where I issued the default route, and I say router OSPF 1 default information originate, and enter. So now if I go to router 3, I ping again 1.1, so I have replied. And what's happened here is that if I do show IP route OSPF, it has inserted the default route to OSPF, as you can see here. Okay, if I go to router 6, for example, I'll do ping 100.1.1.1. Also I have reply. Yeah, that's because there's a lot of processor on my computer. You show the failing, not because there's the problem. Because so now it's back showing to you. So now finally issue ping from router 1 to loop back R2, R3, R4, R5 and 6. If you have successful ping reply, then your tests are well done. So I would try to do only to router, let's say 5 and 6. Ping 5555. That's fine. And ping 6666 is good also. So this is our lab for OSPF. I hope you enjoyed the video. I will see you in the other videos. Okay, thank you. Bye bye.